Hello, I'm Kim Yong-sun, majoring in Smart Convergence Consulting at Hansung University. The topic of this presentation is an empirical study on the effect of technical factors on the operational functions of smart factories, focused on the small and medium-sized manufacturing industries. Let's begin the presentation. The presentation will be in the order of introduction, materials and methods, results, discussion. Since the 2008 financial crisis, major industrialized countries such as Germany, the United States, Japan, and Europe are taking steps to revive the manufacturing industry. This is because an increase in the proportion of manufacturing industries leads to increased productivity, facility investment, and exports, and furthermore, creates jobs and boosts the economy as a whole. The Korean government has also announced Manufacturing Innovation 3.0 since 2015, and is pursuing a strategy to revive manufacturing. However, due to the aging population, low birth rate, continuous labor costs, and rising production costs, the global economy is showing long-term economic downturn and limited growth in manufacturing. To overcome these problems, smart factories that incorporate ICT technology into manufacturing facilities are emerging as an alternative. Smart factory is a future factory that integrates the entire process of product planning, design, production, distribution, and sales into information and communication technology to produce customized products at minimum cost and time. However, although the number of smart factories has increased, the construction level is mostly at the basic level due to various constraints, and it is difficult to operate the smart factories. Looking at the previous research, it was studied that cost, lack of manpower, lack of awareness, difficulty in the program, and organizational resistance are factors that hinder the introduction of smart factories. However, research on the problems of small and medium-sized manufacturers that introduce and operate smart factories is insufficient. Therefore, this study aimed to analyze the effect of technological constraints on the core functions of smart factory operation for companies introducing smart factories. The population and sample characteristics are shown in the following table. A questionnaire was used to measure the effect of technological constraints on the key operational functions and user satisfaction of smart factories. The subject of the survey was conducted for smart factory personnel working for small and medium-sized manufacturing companies regardless of the type of business. The survey was conducted through distribution by mail or e-mail. Statistical analysis was performed on the final 174 valid questionnaires, excluding the 4 questionnaire responses that were considered inconsistent or inconsistent among the collected survey responses. SPSS and AMOS were used for statistical characteristics of samples, validity of measurement variables, reliability measurements, conformity analysis of measurement models, and hypothesis verification. Research MODELs are as follows. Independent variables are set as resource and capacity factors and infrastructure factors for technology constraints. The parameter was smart factory operation function, and the dependent variable was set to user satisfaction. As a result of factor analysis, one item out of a total of 23 items was less than 0.4, so it was excluded from the analysis item. Since most Cronbach S values are maintained at 0.8 or higher, it can be said that the reliability of measurement tools is high. As a result, reliability was secured in all of the resources and capabilities, infrastructure, core functions of the smart factory, and user satisfaction variables, so there were no variables that could hinder reliability. The measurement model analysis is as follows. In order to generate the goodness of fit presented in the final question, the process of removing the measurement variable based on the SMC value, which is the degree of explaining the latent variable, was repeated. Finally, of the 22 items, 2 items of resources and capabilities, 6 items of the cooperation functions of the smart factory, and 1 item of user satisfaction were removed. As a result of analysis, it was confirmed that the t-value for estimating the relationship between the latent variable and the measured variable exceeded 1.965, and the standardized coefficient value was measured to be 0.3 or higher, so that the latent variable well explained the variance of the measured variables. In addition, the metric model values were found to be suitable. The study model was found to be suitable and the path coefficient was confirmed for a specific hypothesis test. The higher the resources and capabilities, the higher the core functions of the smart factory, and the higher the infrastructure, the higher the core factory functions of the smart factory. Also, the higher the core operation function of the smart factory, the higher the user satisfaction. But now the results do not represent the entire SME. Also, the survey method is not objective because it depends on the questionnaire response. Therefore, we can obtain better research results by subdividing the research subjects, separating the groups based on various characteristics, and analyzing the cluster analysis, or the control effect. But now the results do not represent the entire SME. Also, the survey method is not objective because it depends on the questionnaire response. Therefore, we can obtain better research results by subdividing the research subjects, separating the groups based on various characteristics, and analyzing the cluster analysis, or the control effect. The references are as follows. Thank you for listening so far. I'll finish the presentation with this.